424. Longest repeating character replacement. Given a string S that consists of only uppercase English letters, you can perform at most k operations on that string. In one operation, you may choose any character of the string and change it to any other uppercase English character. Find the length of the longest substring containing all repeating letters you get after performing the above operation. Both the string's length and k will not exceed 10 to the fourth, which is 10,000, I think. I always messed that up. String AB. Okay, let's look at some examples. Replace the two A's with two B's or vice versa. Any other? Are these only uppercase? Okay, I think I misread that. Find the length of the longest substring containing all the repeating letters that you can get after performing the above operation. Okay, it's a little remarkable. Let's see. And k could be 10 to the fourth. Okay. So yeah, so the first thing I think about when I see this problem, and not even think about rolling windows yet, is that n k is 10 to the fourth, so that's 10,000. So what I'm thinking is that 10,000 squared is going to be too slow, right? So n square algorithms are out of the question, because I think that's the naive solution, is that you just calculate all the substrings or something like that. Maybe the naive was actually n to the cube, but you could probably do something smarter with the naive algorithm to make it n squared. But that said, we're not going to dig into it that much because it's still not fast enough, right? So beyond that, I'm thinking about like either n log n and O of n algorithms, and those would be fast enough. And for me, the first thing that, and I think that probably helps answer your question a little bit, is that the reason is rolling window, right? And rolling window fits the pattern, or the two pointers, if you want to call it that, is because so with rolling windows, the idea is that you have some invariant that you have some invariant that as you kind of, so you have two pointers, two fingers. So you sometimes hear it as two fingers algorithm because you're pointing with your fingers, I guess. But what it means is that everything within those fingers is certain condition is true, and as you move your fingers, they stay true, or at least at the end of moving your fingers, because another way is like, okay, you move one of your fingers, certain number of positions, and then that means you have to move the other finger certain number of positions to still keep the invariant true, to hold certain conditions true. So that's kind of like the idea behind it. And then I would think about applying it here, because for k is 0 to 2 in this case, or for any k, right? For any k, what does that mean, right? For any k, it means you could change any character to any other character. But another way of phrasing that is just that, like, for any character, it doesn't really matter, right? And I think one thing that and maybe you could do better than this, but when I think about these kind of problems, I just try to think about, well, in terms of for competitive programming, like what is the least that I can do to get away with it, in terms of both performance and coding. And one thing that is important in kind of that realm is kind of getting what n is, right? And I said before, n is 10 to the fourth. But I think one thing that, and k is also 10 to the fourth, though, is less relevant. But the thing to kind of note is that there are additional constraints in this problem that it may not be immediately clear, which is why we practice, I think. So that's you see patterns, but also certain properties of certain problems. When you see it, you're like, oh, because of this, right? And for this problem, for me, noticing that it's uppercase English letters, that means that the alphabet is 26 letters, right? I mean, it's obvious when you say out loud, but when you look at that and you combine it with the string length, that means because n is 10 to the fourth, which is 10,000, 1,000, no 10,000. So 10,000 times 26 is just 260,000, which is going to be fast enough. And that's how I think I'm going to do it, because now we reduce the problem to okay, let's say given a string of size n and given the input k, we could just check for the longest substring that contains only a's, and then that problem again is and you can reduce it to k portion to just having k or up to k characters that are not a's, and you kind of keep on going it that way, and then playing golf here, but yeah, from that. That should be good enough to solve this problem. So, and there'll be, yeah, I guess I didn't talk about complexity in the earlier problems, though I usually do, but it was, in this case, it was generally straightforward because it was linear. But yeah, so that's how I'm going to start programming. I hope that it's okay. But yeah, hey, I'm Wax. Hey, how you doing? Nice to see you. And thanks for the code golf, Bruno Kazui. And thanks for the file, no face killer. But yeah, C++, please. Okay, fine. Yeah. I will take requests on languages too, as long as I know them, obviously. Because if I don't, then I'll just be like, well, just imagine that I did it. Cool. But yeah, hopefully that's a good enough explanation for us to start. And I think I talk about problem solving in this on this channel before, which is that I think one thing that I urge you to do, or people to do in general, is that even if you know the algorithm, make sure you code it, because there are nuances that you will find as you're coding it that just knowing the algorithm is not going to help you enough, and so give yourself the opportunity to practice implementing algorithms, right? So hopefully, in this case, for example, I've explained the algorithm a little bit. And how I would approach it. Well, try to implement it without, just copy and pasting. But that's what I'm going to try to do here. So yeah, cool. So I think, as I said, I'm going to do just start with a brute force kind of way, just each character. So that's just. I still like to do C style because things looks a little weird for me because I am a noob. And then now we could set up each sub problem, and maybe we could even use a helper if you want to be clean about it. Yeah, let's do that actually. Try to be a better person this decade. What would I call it? Oh yeah, let's just go. Best character replacement, some string S and K, and some char C. And then now that means this function is just in best is equal to say 0, best is equal to max of well, just the best, and then best character replacement of C, S, and K. Oops. And then now we just return the best. And then here, as we said, what is the best character given that? So then now we start with the right. So we start, but I always label them left or right, or sometimes head and tail. But definitely, get used to a consistent style. Adding another dimension. What? Yeah, yeah. I mean, you got to type the lease. So I was reading that. It is something that is kind of. I mean, I would say definitely for most people. I mean, I try to explain my thought process around typing and stuff like that. But definitely for most people, I wouldn't worry about it. Definitely not ideal. And usually when I optimize for speed in typing, I do optimize for two things. One is obviously just the speed and code size in general, but that's not the most important thing. Like certain, but I think I also optimize a little bit for codability because sometimes there may be short code, but the complexity is just not worth it. So it's like a trade-off, and then just having code that you're confident with submitting at the first try. That's how I would think about it. But yeah, okay. So now let's just go. I just say white as you go. I guess I'm repeating myself. Also, that I was going to write I, but technically it's a unsigned int is the what you call it. So, but I'm just gonna ignore that and just cast it to an int. I actually got binned by that before though, so that's why I do it this way. Also, just that link, that size rather. That's what happens when you switch between languages. Okay, so given this, we keep track. So this is kind of like the beginning of your rolling window. Let's keep a thing to return. Let's return that at the end. But also, well, we know that, okay, we'll skip that into that bit. So what we're trying to keep track is currently the number of things that are not A's or whatever character that the input character while you're doing it, right? So let's just keep track of that, which is, let's just go used. Sliding window. Well, I actually used to call it two fingers algorithm a lot. I also heard two pointers a lot, but yeah. So let's set use is equal to 0. So that's if. So now you're rolling. So remember, you have two fingers and you're rolling one of them. It's my right. I don't know if this thing is mirrored, so hopefully I'm moving the right way. I don't know, but you're moving one of your fingers, and then that means you're processing one character, which is the string. So if string character is not equal to C, then we use up a character, we increment it, and then now, and I always say use stuff like this in a while loop, even though usually it doesn't have to be. Maybe that's not true, but yeah, while used is greater than k, that means that you know more than k characters are not A or whatever the character is. So then now we want to move to left, right? So so then if the left is not equal to C, that means we remove one of these. So then used minus minus, and then just left plus plus. And in theory, I would bound check more, but there is an implicit kind of invariant in that you don't have to check left for bound because, and there might be typos, so that could happen. But if you have done this correctly, which is not always a guarantee, then because right is always less than s of len, then the sum of the number of used characters will always be like you can't even get used as equal to 0 because, well, in this case that would be true anyway. But yeah, so the left is always going to be less than right, even though it doesn't explicitly happen. And maybe but yeah. Look, I just like waving my fingers, maybe, all right? But yeah, but now after processing one character, now you have to figure out the size of your thing. And then for that, it is just the current best is equal to right minus left plus 1, and that's it. And kind of the thing that is that why I talking about that one. The thing that's always a little tricky for me with these things, and I might even get this wrong to be honest, just because it's off by 1. And off by 1 is tricky, and I think that's where you have to really be careful and define your left and the right. And in this case, and it's not always clear and that's why I sometimes get it wrong, and that's why I have to remind myself. I think like a couple of contests ago, which is a couple of weeks ago, I ran into an issue which cost me like a lot of time, even though I did everything else really quickly. But the thing is that in this case, the right represents the inclusive bound, where the left represents the exclusive bound, right? And what I mean is that in this, if you think about them as boundaries, the right will contain S sub right, where the left will not contain S sub left, to be clear. And this is why there's a +1 here. But we also have an implicit thing where like we always have at least one element. Is that true? Maybe that gets a little weird. Let me test that case actually. But yeah, can KU is 0? I guess so. Let's just play around. There are a lot of test cases we can do here, but that's the things that I would kind of think about as well for testing. This will always would this always return 1? Yeah, because I guess left catches up to right. And then it always returns 1 character, even if that character is not in the set. It's just that it gets invalidated because your answer is always going to be at least 1, so that's why it's not an issue. But there is an actual, I think there's an off by 1 here somewhere. I think you have to check something like if, like in theory, you want to be, depending on the problem, you have to check that if left is equal to right, and S of right is equal to C, then you could do something like this. Otherwise, technically, the answer would be 0 because technically your left should be 1 space ahead of the right to kind of make that math work. But because of the invariant that we were talking about, that would not happen. So that's kind of an edge case, but I don't think that actually happens only because in this case, we try 4 characters, and in that case, the answer is always going to be 1 because every character is going to, like your smallest answer is always going to be 1, and the input is 0. Let's try that. Can you get an empty string? But then in that case, you'll just be 0 because it won't go into the for loop bit. Maybe I should just submit it. Maybe I'm being a little bit too cautious, but that's kind of how the things that I would talk about. Okay, let's just submit it. Maybe I will miss something silly, or maybe I get timeout and then I said all that stuff for no reason. Okay, wow, people are way faster than I am, so clearly I did something lazier. But yeah. What else is there to say about it? I mean, as you probably know, that's why you requested this question. There are a lot of there are a lot of sliding windows type questions or rolling windows and all that stuff, right? So definitely practice this, and I think even if you know how to solve it, I would still recommend just coding it, because I think especially with sliding windows, particularly, excuse me. Especially with sliding windows, there are a lot of off by 1 opportunities, and I consider myself experienced, and I still make silly mistakes of off by 1 with sliding windows. So definitely coding is an important part of it. I mean, maybe in an interview, like off by 1 is not as critical because they may just hand wave it, but still, you shouldn't rely on that. So definitely practice on that, and I would definitely recommend it. I think this problem for medium sounds about right. There are a couple of logical steps you have to make, so it's reasonable. I think, as I mentioned it, the complexity of this is of alpha times n, where alpha is the size of the alphabet, which sometimes gets hand waved into being linear, which is maybe fair, but if your size of the alphabet is huge or infinite, then like you can't do this, obviously. But yeah, and actually, I think you could do slightly better even if you're Yeah, I think I could have done a little bit better. If your alphabet, even if your technically your alphabet it could be big, your alphabet will be bound by the n. So even if your alphabet it gets really huge, the size of your alphabet to be precise, then at worst it'll be n squared, right? Because you just ignored out calcs that you haven't used, which is an optimization that I did not do. Because in theory, and maybe that's probably why it's so slow by comparison to other submissions, which is something that I didn't think about because I didn't need to think about. But maybe in an interview, that's what you would bring up is that, for example, in this string, we only use A's and B's. So there's no need to look at like C's and D's and so forth, right? Which is an obvious statement and an obvious optimization after it is pointed out. But in an interview, you obviously should point it out. But yeah, but in a general case, this is of alphabet times n, and I do not use any extra space. I mean, constant size extra space. So actually, all of one extra space. So yeah, that's kind of the solution for this problem. Yeah, let me know if you all have questions. But I think that's all I have to talk about for this problem because I front loaded a lot of the talking about. But yeah, cool.